welcome. I'm glad after the brief introduction of an ellipse, you came back to learn more about them, okay? Now that you know how to construct an ellipse, right? How do you start? You start with the foci, two fixed points, and then you have the distance, right? So you attach a string, the foci 1 and foci 2, and you stretch it out. And you know, D1 and D2 don't change any, they stay constant. They don't change any distance. The length of the D1 and D2 don't change, okay? So when you pull it, you go around and you create an ellipse that looks like this, right? Okay, it looks like a little bit of a distorted circle, right? And that's what actually an ellipse is, okay? And if you guys remember the intro videos when we were beginning this conic section, remember how we had a cone? And the cone, the way we slice it creates all these conic sections, right? Well, the ellipse, I don't know if you remember, it's the one where you go straight through left and right, okay? That's how you get an ellipse. A parabola, I think you guys remember, it's a little bit slanted, right? Okay, an ellipse went straight through, okay? Now that we've described that already, let's actually move on to just dissecting what the ellipse and all of its parts. Remember, a parabola has a vertex, it also has a focus, it also has a directrix, right? Well, an ellipse has all these parts that you see here. All these parts here, all these parts, okay? And now, this ellipse is actually, now let's compare Mr. V and Miss Chang. Mr. V has sort of a longer face, right? Miss Chang has more of a rounder face. So this will be Miss Chang's face, okay? Now, if you're looking at Miss Chang's face, it's longer this way, okay? So if this was Miss Chang's face, it's longer this way. And that's why in an ellipse that looks like this, the major axis is longer. And that's just like, guys, use common sense. Major sounds longer than the minor, doesn't it? So let's actually, I'm going to actually write some couple of notes here for you that you can write for yourself as well, okay? So obviously, major axis, okay, is longer than minor axis. Okay, and look where the major axis exists, okay, in the horizontal. This one's longer this way, so we're going to call this a horizontal ellipse. So the major axis is longer than a minor axis. Let's see what else we know. Actually, you know what I'm going to do? I'm going to actually draw some lines for us so then we can see what I'm talking about. So do you understand what I'm talking about with the major axis? Major axis is here to here, right? You see that? Okay, and the minor axis, where is minor axis? It's actually the shorter one from here to here, right? That's the minor axis. Now, center. You see the center? Center is what you know as a center. Center, you always know it's in the center of something. Like a circle, if it was a circle, it's in the dead center, right? Okay, now the major axis lies along, okay, the major axis. Now, I meant the vertices. You see the vertices here? So let's write some more. The vertices, vertices, okay, lie along the major axis. Now, I know that there's endpoints on the minor axis as well. However, the vertices only occur on the major axis, okay? Vertices lying along the only. Maybe I should write here, only, okay? Okay, now what else can we talk about? Let's talk about, okay, how about the foci? Where is the foci? You know how there's two focuses? So we call that foci. Where is the foci? Well, the foci lies here. So you know what I'm going to do with the foci? I'm going to put stars at the foci. Not too big. Okay, I don't want to make it too big, so I'm going to go like this. The foci are along where? The major, of course. Everything happens on the major, guys. Doesn't happen on the minor, okay? Now, major here. That's where the foci occur. So, like, I'm going to put the star here, too, so you can see that foci is a star. And foci lie along the major axis. So, lots of action happening at the major axis. All right? Okay, let's see what else I have to mention to you. Okay. Some of the distances from any point, I think we're good so far, okay? Now, I have a question for you, something to think about, something to chew on. Now, ellipse, okay, an ellipse is here. Now, what do you think about a circle, okay? Now, all right, now the more we talk about an ellipse, I think you'll get better ideas. So let's keep going, okay? And then I'll come back to that question, okay? All right, now I want you guys to understand, I'm going to give you the equations for the actual circle, but what I want you to understand is that you can find the full proof, which is really elaborate and long, on page 704 and 705 of your textbook. So make sure you take a look. I know some of you guys are really, really curious, so I don't want to take that away from you. All right, so let's move on to the equations, right? STD forms, right? The standard form, okay? Standard form of the equation of an ellipse, okay? With the center HK, you know the center is always in Hong Kong. Center is always in Hong Kong. Center is always in Hong Kong, okay? And major and minor axes of length 2A and 2B respectively, where 0 is less than B is less than A. That means A is the greatest, obviously. And of course, these are length, so they have to be positive. That's why it's greater than 0. Okay? Now 2A and 2B, let's see what those differences are. First of all, here, I know what you see. You see Mr. V is here at the bottom, and you see Ms. Chang at the top. That's a horizontal. This is a horizontal. I'm gonna write that here for you. Okay? This is a horizontal. This is a horizontal ellipse. Oh my God. Okay, this is a horizontal ellipse right here. And the one you see at the bottom here, you see the one at the bottom here, the one that looks like Mr. V? What do you think that's called? Maybe we should write it here. This is a vertical. Why is it vertical? Because this one is longer, lengthwise, right? Height. Longer, taller. Okay, I don't know if you want to talk about taller. So this was horizontal, and this one is horizontal because it's just, I guess, fatter. Okay, is what you can say. Okay, it's just longer, left to right. Now, you see the similarity between the vertical ellipse and the horizontal ellipse. Yeah. Oops, sorry about that. You see the vertical ellipse and the horizontal ellipse. The actual difference in the equation. What's the only difference that you notice? Okay, and what's something familiar to you, perhaps? Okay, I know some of you guys are thinking, okay, if I take away, you guys think about it. Imagine if you take away this stuff here. Let's take away this, okay? Let's take away this. What is that equation then? It's a circle, exactly. I know that's what you were thinking, okay? But we have something that distorted the circle. So you're right, an ellipse is a distorted circle. It's a circle that's been crushed or actually been pushed, squashed. Okay, think of it that way. Now, for a horizontal ellipse, you can see that the major axis is on the bottom here. So 2A. Actually, A is always the major. So let's write that, okay? Let's write some comments here. Okay, A, lowercase a, lowercase a. I'm gonna go like this, okay? Always stands for the major axis. But it's actually half of the major axis. Half of. Doesn't it look like the half of it? Like 1A is from the center to the vertex. Half of major axis. That's why we need 2 to complete the major axis. B, okay, always stands for the minor axis. Okay? And that's why, or we could say half of minor axes, right? So let's write that too. Sorry, minor axes. Okay? And that's why you can see how the horizontal ellipse and the vertical ellipse looks like this. X, Y, they're the same on the top, right? But then A and B are swapped because the longer happens on the Y-axis. See, the major happens on the vertical ellipse. The major happens on the Y-axis, whereas in the horizontal ellipse, the longer or the major axis occurs on the X-axis, and that's why this equation makes sense. Okay? Don't try to just memorize these formulas, but instead try to think about how can I remember these? What are ways to remember them better? Okay? Smartly, with thought. Okay? Now you might be wondering where the factor is the foci, right? And the foci, it is lies along the major axes, right? So let's write the foci there. So I'm going to put a little star again, but I'm going to put a little tiny star on the foci for each. So there's a foci here. Later, when you get really good at this, you guys, you know what's going to happen? You're going to see where the foci is in terms of the center. Is it closer to the center, farther away from the center? And what if it's closer or farther away from the center? How does the ellipse shape change? Shape of the ellipse change. You're going to be able to determine that too, okay? So now, the stars go where for the vertical ellipse? The vertical ellipse, it'll go along the major axes, right? So we're going to put that along the major axes as well. So those are the foci. And if you guys can't remember what the stars are for, why don't we type that in for us, okay? Let's write here that this is the foci. Stars are the foci. Okay, write that for yourself on your notes. Okay, I don't know if you're handwriting it or what, but do that, okay? All right, let's move down to the actual, there's a nice proof for you. Let's go here. There's something, and I'll see you back in class, okay? Bye.